All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So on this one, you're going to have to do a remove, replace, reduce. We're going to start by removing the 7 by multiplying it by that 16 over here. And so now we're going to factor this. And don't forget that you want to replace your 7 in front of your x squared. The two numbers you're going to want to use are negative 56 and positive 2. This first set will divide by 7. And then we have 7x squared plus 2. And so that would be your answer for your factoring. For the math knowledge question, y varies directly. That means that the product of w squared and x, when it varies directly, that's going to be in the numerator with your k. Have y equals w squared and x both need to be in your numerator. That is not the case on those two. And inversely a z cubed. That means that your denominator has to have z cubed. That eliminates these two. And your k has to be in your numerator. And the only one that works is 8. So that is the correct equation for his statement. For the lesson, we are looking at lesson 103 today. We're dealing with calculations with logarithms, and then we're going to look at the power of the hydrogen. So these calculations with logarithms, right now, it is strictly practice. We will actually use it in calculus next year whenever we are taking derivatives of some strange looking functions, which you don't know what a derivative is probably. But we will use this concept next year in calculus. And when they go to that lesson, they expect you to understand this concept really well, and they don't explain how to do it. It's just, hey, here it is, how we apply it. So we need to make sure that we understand the concept with these problems. And then the power of the hydrogen, you may have done those in chemistry. So we will look at those too, and hopefully you'll understand them. We want to take this expression and condense it down to one single logarithm. Okay? So right now we have 4 separate logs. And we want to make it one log in the final answer. The first thing that you're going to want to do is to take any number that's in front and move it to the end and make it your exponent. So all of these numbers that are in the front, we're going to move and make it our exponent. So we're going to have the ln of x squared minus 1 to the third minus the ln of y squared minus the ln of x plus 1 to the 4, and then plus ln of y squared plus y to the 2/3. After that, we are going to make it into one log. This first one is going to go in the numerator, so we have x squared minus 1 to the third. The y squared is going to go in the denominator because we have a minus here. And remember, when you have a minus, you are dividing. So we're going to put the y squared in the denominator. We're also going to put the x plus 1 to the fourth in the denominator because of that negative. And then the y squared plus y to the 2/3 is in the numerator because you have a plus sign right here, and so it gets multiplied. Now that is as a single logarithm, but we do have to simplify this. The way that you can simplify this, x squared plus 1 will factor, and it'll factor as x plus 1 times x minus 1. Now we have 3 x squared plus 1s because it's a cube right here. So these are both going to have a power of a 3. Now this y squared plus y. I'm going to just look at y squared plus y. You can factor out a y, and you're left with y plus 1. Now this was raised to the 2/3. So when we go to simplify that, we're going to have to put a 2/3 here and a 2/3 on that one, okay? Because the exponent on it is still going to be a 2/3. So we can say y to the 2/3 and then y plus 1 to the 2/3. And then we have y squared and x plus 1 to the 4th. So now we can cancel all three of these with all but one of those x plus 1s in the denominator. And then this x squared and x to the 2/3, you can subtract. We have 2/3 over y squared. You can say 2 minus 2/3, and that's going to give you 4/3. So that's what we would be left with in the denominator. So our answer is going to look like this. The ln of x minus 1 cubed, and we have y plus 1 to the 2/3 over, instead of that y squared, it's going to become y to the 4/3. And then we have x plus 1. And so this would be your answer. So once you get it into one log, you do have to make sure to simplify it if you can. Now, we're going to take this and we're going to expand it into a sum of log expressions. So it's basically working backwards from what we just did. So we're going to start by making it the log of x y cubed minus the log of the square root of x plus 1c cubed. So that's the first thing. I'm going to split my numerator and my denominator apart. So now, these two terms here, it'll split into two terms where you are having log of x plus log of y cubed. Because you're multiplying, you can split them with a positive sign. On this next one, we have a radical, and the way we can get rid of that is to make it 1/2 log of x plus 1 z cubed. Now on the log x, we can't really simplify that any further, so we'll leave it as log x. The log of y cubed, the only thing we can do is make it 3 log y. And the reason we need to do that, it says up here, the argument is linear. So that means that log of whatever it is needs to have no exponent. So we have to move that exponent to the front to make it linear. Now on this last part, now we have two pieces. We have x plus 1 and we have z to the 3rd. So we are going to make it into two logs, the log of x plus 1 plus the log of z cubed. Now, I put parentheses around those because while they are both being multiplied, we put a plus sign there, they are also both having the property of negative 1/2 in front of them. So we actually need to distribute that negative 1/2. So we have log of x plus 3 log of y minus 1/2 log of x plus y, and then minus, it would be 1/2, but we've got a 3 for our exponent, so we can really make it 3/2 log of z. And so this whole thing is going to be your answer there. So that's how you expand and condense your logs using your properties of logs. Moving on to the power of the hydrogen. This equation is in exponential form, and we can rewrite that in log form by saying the pH equals negative log of H positive. Your pH, remember, ranges from 0 to 14. That should have been covered in chemistry. And then that H positive, it represents the concentration of hydrogen ions. Okay? So we are going to use one of these two formulas. You will need to learn them. Now you can take one and put it into the other. If we take the log, or we put this into exponential, take it from exponential and put it into log form, we'd have log base 10 of H positive equals negative pH. And so then if you just switch your signs, you have negative log base 10 of H positive equals your pH. Okay, so you're going to be using one of those two forms on these questions. It says to find the pH of a liquid if the H positive is 4.03 times 10 to the negative 6 mole per liter. So we need to use one of those forms. We're going to use the one where it has pH equals negative log of H positive because we're solving for the pH. So we would plug in negative log 4.03 times 10 to the negative 6. And if you plug that into your calculator, you should get 5.39 for your pH. If I had gotten a negative number, or I had gotten a number greater than 14, that is not going to be the pH because your pH ranges from 0 to 14. Okay, so if you know a little bit about pH, you'll know that your answer is either a possible pH or it is not possible. Looking at another example, we want to find the concentration of hydrogen ions, that's the H positive, if the pH of the liquid is 7.05. So we are going to use the 10 to the negative pH equals H positive. So H positive is going to be 10 to the negative 7.05. So 10 to the negative 7.05 gives us 8.9 times 10 to the negative 8 for our concentration of hydrogen ions. And so that would be your answer for that example. So your homework, you do get to omit number 1 and 14 tonight. So make sure that you do those other 28 problems, and then we can go over any questions you have tomorrow.